So today we'll be going through Scala. So what is the purpose of Scala and how we can use it in Databricks? So apart from the different languages that we have or the coding languages that we can use in a notebook, Scala is one of them. So basically, apart from Python, SQL, and R, PySpark being the default language that you can use in Databricks notebook, we can also use Scala. So if you're asked like what is Scala? Scala is basically a high-level multi-paradigm programming language that combines both functional and object-oriented programming concepts. It's renowned for its concise syntax and is widely used in big data applications, especially along with Apache Spark. The reason for this close relationship with Apache Spark is that Spark itself is written in Scala, making it an ideal language for interacting with Spark's distributed compute engine. Okay. Now, let's go ahead and look at the codes. Okay. So earlier, if you remember, earlier, if you go ahead and take my earlier or look at my earlier videos on Databricks, I have uploaded my file into file store tables, and the two files that I've uploaded is customers and orders. Okay, just to walk you through how I did it. So I use now upload data. After using upload data, so I come here in the DBFS. I'll upload the files in the DBFS. So upload files to DBFS. I'll click here and then I can just browse and I'll just use the default location. If I want to create an additional location and all, I can create that as well. But for now, I'll just go ahead and save my files in the default location, which is uh, file store table. So basically, I can just browse and upload my files, customers and see customers and orders, or any of the files that you are comfortable with. Okay. Now let's go back to the notebook. Okay. So now if we go back to our notebook, okay. So make sure it is connected to a cluster. So created a cluster. Now, how to create a cluster and all, you can find those details in earlier videos as well. Okay. Now, as I said, so the first line. So we have to start off with Scala code. So we have to use the magic command of something like this. So I can use Scala, or else I can just go ahead and using this option, I just select Scala. So now it will accept the codes in the form of Scala. Okay. Now this particular code snippet executed within a Spark environment, and this is a magic command. And then what we have is basically like our files are stored in file store tables path. Okay. So there are some libraries that we need. So data frame, Spark session, struct type, struct field, struct type. So we'll use some of the libraries. Let me just go ahead and bring it in. So I'll use import or dot Apache dot Spark. Frame. Then I also use Spark session. Okay. And then I'll also bring in another library. Spark. Oops. Okay. From types, I'm doing so type. So, field, integer type. Then I also going stamp type. And Okay, so first in this particular step, or this particular step, it imports data frame, Spark session, and various data types from org.apache.spark SQL package and its sub packages. So these are essential basically for working with Spark data frames and defining schemas. Okay. Now, next we will load data frames. Okay. Now, to load data frames, should probably do it. But before that, let me just go ahead and test it if it's okay. Okay. Now, so if I go ahead and execute, okay. So now looks good. So I'll go to a new cell and then I'll load customers data frame. So now load customer the data frame. So let me just first load and then I'll go ahead and explain the code. So if I source path is going to okay. So I'm defining the path here, path here, and then the variable customer data frame. Okay. Um, customer data frame and now to define the data frame. So I'll be using Spark dot read, then I'll use Spark dot read, and then I'll use option. Um, Option, and then header true, and another option infer schema true, CSV customer path. Okay, and then I'll also create another one for uh, orders. So I'll define something very similar. Okay. Um, all this one is orders. Spark. Keep it uniform. So I keep it orders and customers. Orders. So this is so let me confirm. Orders path. This is the path. So orders data frame is equal to spark dot read dot the option, but option info schema versus p orders path. Now this looks good. Now, if I want to print schema, so basically what this does, so it defines the path of two CSV files. Okay. So what we have is file store tables customers and then file store table orders. It uses spark.read to load each CSV file into a Spark data frame, customers DF and orders DF, and then header true. So this option header true. This tells Spark that the first row of the CSV file contains the column headers, and then option infer schema true tells Spark to automatically determine the data types of the columns based on the data in the CSV. Okay. Now, yeah, so now let's go ahead and execute. Just a second. So I did not realize. So basically, I'm trying to execute the code, but I have used Python. Okay, so rather than using Python, I'll just go ahead and use Scala. Okay. So now if I go ahead and execute, Okay, so now my data frames have been created. Okay, so next we will print the schema to verify, okay, whether our data frames have been created properly or not. So to do that, so we can use first use okay. So I'll use print so student and then I mean if I want to print any text, so I can use println and then I can use uh, stems schema and then I can to basically print it out. So I can use stems df or print schema. Okay. In same way, if I want to print orders, so I use print um, I use orders df schema. Now, this customers.print schema and orders.print schema display the inferred schema that is basically column names and data types of each data frame. And this is useful for verifying that Spark has created correctly the interpreted I mean the data frames, okay, or Spark has correctly interpreted the data structure the files. Okay. Now, if we go ahead and execute. Okay, so now you can see the data types. So yeah, ID, name, segment, so all are string. And for orders, this is an integer. If timestamp, then this is string, and then this is done. Okay, so we are good. Now, next what we will do is basically so after printing the schema, if I want to look at some of the records, I can also do it. Okay. So just like in Python, we have add, or in PySpark we use show. We can also use show here as well. Okay. So for example, if I want to use schema code, okay, I can use customers df or show, and then I want to see just 5 records. Okay. And then I want to also see orders df dot show. You can use 5 records. Okay, so now if I go ahead and execute, so this is what I see. So basically, the dot show displays the first 5 records of each data frame. This you can use basically to quickly look at what the data holds, okay, or what type of data the data frame is going to be. Okay. Um, Next, we will go ahead and display schema. Okay. So I have to, before even going for when condition, so I have to import this library first. So I have to import like, so I have to use import dot spark functions. So okay. Now, this basically helps us import all the available functions. Dot underscore, so this basically helps us import all the available functions. Okay. Now, if I want to add, now if I go ahead and execute, so it will work. So what I'm doing, so I'm using import from all the Apache. uh, dot SQL functions. I'm importing this. So then I'm creating a data frame, orders, uh, categorize orders data frame. Here I'm adding the column which is called as order category. So order category basically has these conditions. So sales greater than 1500 high value, greater than 500 medium value, and otherwise low value. So then I'm displaying the top 10 value. So now if I go ahead and execute, okay, so now you can see, so now I've created a calculated column. Okay. Now, apart from that, if I want to do some other manipulations, like for example, if I want to write a select statement on top of this table, I can also do that. Like for example, just show you. So, so I'll create a new data frame. So I'll use val. I'll call it as customers states df, and I'll use customers df dot. Now I can use this select clause. Okay, so I'll use select. Okay, select name. Then I want to use state. Okay. Next, if I just go ahead and show customer states df, show 10 records. Okay. So now if I go ahead and execute, so basically I'm just selecting two columns from the entire table. Okay. Now, apart from that, if I want to add filters, okay. So if I want to add filters, I can also add filters. Show you. Um, so I click on the data frame. So I call it as I value first data frame, which is equal to. So I'll use, okay. This is what I'll use. So orders data frame dot filter, and sales value I will use as greater than 1000. Okay. That's it. So now if I go ahead and so now I've also print it out, right? So I'll also print out. So I value orders dot show numbers. Okay. So now if I go ahead and execute some, sorry, and I'm not supposed to use this. Um, Without call also it will work. Others, then red, it sales is greater than percent. Execute. Um, Orders table is not defined. First, second, using the table correctly, name of the table. Okay, because I'm not using Scala. Not sure. Still an error. Let's see what's the error. Yeah. Um, Create the value. Uh, occurs. So yeah, some errors in the syntax. So you have to use val and then use the data frame. Okay. was define it as a variable. Now, okay. Next, so yeah, so this is basically how I can filter it out. Now, you can also use objects for a more safe type of approach. So this is one approach of adding a filter. Now, if I want to use it a little differently, I can also do that. Like, for example, I can use, I'll use the same code, but yeah, I'll use it a little different. Now, rather than using directly sales, so I can also use the call function. So I can use call then sales greater than. This is also another approach. So basically, for example, sales have to. Sorry. Okay. So now you can see what is I'm able to filter it out on sales. Okay. Now, if I want to add multiple filters, I can keep adding. Dot CS or dot filter, and then I keep adding more and more conditions as well. Okay. Now, so we completed filters, we have completed conditions. Now let's go and look at join. Okay. Now the condition, the situation what we will be doing is basically we will aggregate to find total sales per state. Okay. So when we work with that particular condition. Okay. Now let's go ahead. So first, in Scala is the magic of Scala. Now its value, state, six. Okay. And then we will use orders df, and then we first create a join. Use customers df, and then the two tables that we want to join along with the keyword. Along with the primary key. String square ID. This is where we will provide the condition like the something. So then we will use system df ID. So I want to create the relationship on ID. And then what type of join that we want? Basically, we want inner join, right? So I just go ahead and create inner join. So this is the code. So now after creating this inner join, so I also want to add some aggregations on top of. Okay. Now just confirm. So while state sales tf or state dot join customers. So relationship customer. Okay. So now this. So now on top of it, I also want to add some groupings as well. So I'll be grouping on state, and then I aggregate on sales. Okay. And create a name of this aggregated table. I'll create an alias name of this aggregated table. I'll call it as total sales. Okay. Now to do that, basically, I can use so dot group by, and I'll use a group by set by state. Then listen, I'll do an aggregation. So I'll aggregate. So I want to aggregate on sum, right? So I'll provide sum of sales. Okay. So I'll use sum of sales, but yeah, I want to put the groups. Okay. And then create an alias name. So I'll use dot as, and then I'll provide alias name as sales. Okay. Now I also want to sort. Okay. So now if I want to sort this, I can use dot sort. Then I want to sort it descending. So either I can sort it descending or ascending. Okay. So I'll use descending sort, and I want to sort it on the alias name. Okay. That's it. So now what I've done, so basically I've created a relationship. Then I grouped by on state. I did an aggregation of sum of sales, but yeah, apart from sum, there are also other aggregations like um, all these aggregations are available, like average, like minimum, max. So depending on your needs, you can do that. So for now, you just go ahead and use sum. Okay. Distinct sum. So there are many aggregations available. So you can explore that as well. Okay. So now, once my data frame is created, so I can just go ahead and look at it. So state sales dot show then records. Okay. So now if I go ahead and execute. Okay. So now you see since I've grouped by state and sales, so basically I'm getting total sales. Okay. So this is like in the inner chain. Next, I mean, I'll show you like we already created the joins. Next, I'll show you one more example where we will do some, we'll use a different aggregation. Okay. Now, so this time what we will do, we will join customers and orders to find out total sales per segment. Okay. So let me take that as an example. So I create val sales segment data frame is equal to orders will be in the fifth. I'll use first to left. To left. ID. Okay. So now this time we'll do it differently. So I'll use uh, group by. So this time I'll group by from our from segment, okay, or I'll group by on segment. So I use group by segment. Then I do aggregation. Okay. Now this time I'll aggregate I'll first use sum of sales and then I'll also use distinct count. Okay. So I'll use sum of sales. Alias name I'll be providing as total sales. And I'll do another aggregation. So I'll use distinct on ID that is present in customers data flow. Okay. So I'll use customers data frame, count of IDs in customer data. Okay. And I'll also name it as something like this. Number of okay, number of customers. Then I'll also go ahead and number of customers. Okay. And then I'll also sort this. So this is the aggregation. Sort, sort descending. I'll aggregate in totals. Aggregate this on total sales. Okay. Sales. So, um, so what is this for? This. Now, if I want to display so sales by so uh, okay. We can just confirm the let's aggregate this one. Segment. So we go needs to. That's what I was thinking. Yeah. So the error was because of I missed a parenthesis here. So now looks good. So now I can just go and execute. Okay, so now you can see we're getting so segment total sales and number of customers. Okay. Now, we will stop the session at this point. Okay. Next, we will be continuing in our next class. Okay. Thank you.